Hello, very good evening to my dear students. I am Dr.M.L.N.Acharyulu, Department of EC, St. Peter's Engineering College. I would like to continue the lecture of the antenna arrays, which is already discussed about the 2-point sources with the 5 cases in the previous sections. Now we are going to talk about the various types of arrays, and we are going to implement these point source arrays in the broadside identifier also. So here basically used to take the first one is the array of 2-point sources, already completed that. Now we are going to talk about the linear array of n isotopic point sources. After that we will coming to the principle of the pattern multiplication. So now we are going to talk about the various types of arrays like a broadside array, end-fire array, binomial array. Only these 3 topics in our syllabus, and the Dolphy-Chavisho array also there. But we need not worry about this. As per our syllabus, we need to consider only these 3 types of arrays. And of course, I will give the Dolphy-Chavisho array in extension, definitely. And now the different conditions of the array point sources, we used to take the case when the 2 isotopic point sources, same amplitude and the same phase. 2 point sources with equal amplitudes and the opposite phase, already we discussed these 2. And the third case, equal amplitude and the some phase shift, that is 45 degrees or 90 degrees phase shift like that. And the equal amplitude and any phase difference, this is the case 4. Already we discussed in the previous sections about the 3 cases and the 4th case also. Now we are briefing about the 2 point sources, the isotopic sources with the same amplitude and the phase. We have to the total incorporate with the total field pattern and the amplitude field patterns, direction of maximum and minimum also. In this connection, just we go through this. This is the half power point. Whatever we discuss the 2 point sources like this, which is one is at the origin, another one is at the advanced with the point source 2 with respect to the origin. We consider that. Consider the 2 isotopic point sources separated by G at an angle between the coordinates x and the point P. You say that this is the point P and coordinate x is here. So the 2 point sources are placed on the coordinate x. One is at the origin, another one is at the point, some point where this is 2, and the angle subtended is a phi, and this is the towards to the P point source. This is the r cos phi generally, which is indicated here the x. The distance between the 2 point sources d and the phi is the total phase shift, phase difference of 2 field from the point 2 to the 1, point 2 and 1, and at the distance point P in the direction of phi, like this. This is the direction of phi. So from this relation, and the psi phi is equal to 2 pi, that is called the path difference, plus the del is which is plus del, which is radians. These are in phase and the del equal to 0, for example, then the path difference obtained from the above figure, you say that the cos phi is equal to x by d. Where it is, this is x and it is d. So therefore the cos phi is equal to, what is that actual adjacent side by hypotenuse? So from this analysis, just to see, cos phi is equal to x by d from the figure. And similarly, just to take where x is equivalent to the d cos phi, what is x is equal to, again with respect to the lambda we used to take therefore the d by lambda instead of d. So just to take d cos phi by lambda, this is called the x value. So again you used to take the psi value. Psi is equal to 2 pi into x, where 2 pi as it is. What is x? X is nothing but a d by lambda into cos phi. That should be substituted here. And we'll use to take, this is the 2 pi taken as b. Already you know that 2 pi by lambda is equal to beta. What is the value? So that is generally you say that beta is equal to 2 pi by lambda. So according to that, psi is equal to beta d cos phi. Now we are going to take the total field, where E1 far field due to the source 1 in this figure, just you see that this is the far field due to the source 1 and the far field due to the source 2. Which is the far field is placed at the point P, you say that. So we need to take these two are the E1 and E2 respectively. So according to that, the field produced by this array of two elements at a distant point P from the origin 0 is given by the E is equal to E1 plus E2 e power j psi. Already I told all these things. The same derivation is applicable here. So E is equal to E naught plus E naught e power j psi. So again E naught is common here. So therefore E naught e power j psi by 2 is common. So e power minus j psi by 2 plus e power j psi by 2. 2 will be multiplied and division on this. Just you will get the 2 into and division like this. So therefore you will get a 2 E naught is there. By taking the normalization, 2 E naught is equivalent to the 1. So therefore we get E is equal to e power j psi by 2 cos psi by 2. This is called the amplitude. So now we'll consider that the amplitude pattern. Just we'll take a psi by 2 is equal to beta d cos phi by 2. Already know that the beta 2 pi by lambda. So therefore d by 2 into cos phi as it is. Now we will take pi d cos phi by lambda. Now the distance between the 2 point sources is will taken as a lambda by 2. That means if you will consider that the two source points is there, source 1 and source 2, the distance between these 2 points will say d, but you say that lambda by 2, this is the distance between the 2 point sources. Then what we get the answer by using of this d value is a lambda by 2, then psi by 2 is equal to pi by 2 cos phi. Then that is the amplitude of electric field which is equal to cos psi by 2, where cos as it is, instead of psi by 2 you say that pi by 2 cos phi. This is about the amplitude field pattern. Now we will consider that the direction of the maximum. How we are going to take the direction of the maximum? The maximum direction can be obtained by equating the amplitude field pattern to unity. That means you say that the E is equivalent to the 1, you say that. So therefore what is left? Cos pi by 2 cos phi. So which is psi is the maximum. Therefore pi by 2 cos phi max is equal to the cos inverse of plus or minus 1. Now we will take plus or minus k, where k is the value 0, 1, 2, 3 like this. But you take k is equivalent to the 0. Then what we get the maximum? Here pi by 2 cos phi max is equivalent to the 0, because you used to take 0 value. Then the pi by 2 cos phi max is equivalent to the cos inverse of plus or minus 1, just to say, just you may apply which is equivalent to the 0, k equivalent to the. Therefore cos phi max equal to 0, phi maximum is equivalent to the cos inverse 0, then the maximum value attained at 90 degrees and the 270 degrees. When it is a put k is equal to 0. If you will take a put k is equivalent to the 1, what happened? Now we used to take the pi by 2, similarly previously we considered the 0 value here, but we consider that the 1 value. Therefore cos phi max is equal to 2 by pi. So therefore phi max is equal to cos inverse 2 by pi, which is equivalent to the approximately 90 degrees, that is the 89.36 degrees. This is the direction of maximum. This is what? Direction of maximum when cos values at 90 degrees and the 270 degrees. That means the, okay, I will show that this. And now the direction of the minimum. Direction of minimum to get the minimum field direction, equate the amplitude equivalence to the 0, then E equal to 0. Just to see the E equal to 0, therefore the cos pi by 2 cos phi equivalent to the 0, then you will take cos inverse 0 like this, then you used to take the 2k plus 1 into pi by 2. This is the general equation. Now we will take the k is equivalent to 0. By using of these equations, just you will see, put k is equivalent to the 0, therefore pi by 2 cos phi minimum is equivalent to the 2k plus 1 na 2 into 2k plus 1, 2 into 0 plus 1 into pi by 2. Then you will get what is the value? Pi by 2 you will get. then the cos phi minimum is equivalent to the 1, the phi min equal to 0 and 180 degrees. Previously what we have, now the minimum is 0 and 180 degrees and the maximum is 90 and 270 degrees. Now we will take this is the radiation pattern of the given, just to see that the maximum value attained at the 90 degrees and 270 degrees, but on 0 and 180 degrees there is no radiation pattern, that means the minimum. So this is the radiation pattern of the 2-point sources placed at a distance lambda by 2. Now we will consider the half power point direction. Where is the half power point direction? Generally used to take 1 by root 2 of the maximum value is called the half power point or 3 dB points. A half power point power is half and voltage and current 1 by root 2 times maximum, therefore equal to 1 by root 2. Then you will take the cos pi by 2 cos phi, which is equivalent to the cos inverse 1 by root 2. Therefore you will get the general equation is like this. Then when it will come, cos 1 by root 2 will come at the 45 degrees, then cos pi by 4. So therefore 2k plus 1 into pi by 4. Now we will take the cos half power points is equal to 2k plus 1 into pi by 2. That means k is equal to 0. Then you will get the cos phi h, half power points equivalent to the plus or minus 1 by 2. Then the half power points is placed at the 60 and 120 degrees. Then here just to see that from the above analysis, we used to take the maximum attained at the 90 degrees and 270 degrees and the half power points placed at the 60 degrees and 120 degrees, and you will take a minimum attains at the 0 and 180 degrees. This is about the electric field orientation of a given 2-point sources.